Welcome to part 2 of week 5 cis204 Unix shell scripting and utilities, and we're going to be talking about shells now. So let me get my ugly visage off your computer screens here, and we'll jump right in. First, let's talk about POSIX. POSIX is a set of standards for a portable operating system interface. So we've got the POSIX. POSIX.1-2008 defines a standard operating system interface and environment, including a command interpreter. Now, in this case, it's a line command interpreter or shell and common utility programs to support applications portability at the source code level. So the following areas are outside the scope of the POSIX.1-2008. Any graphical interfaces. So the GUI is not part of this POSIX.1-2008. Database management system interfaces, record I/O considerations. In other words, how do you get information back and forth from the disk or memory? Any object or binary code portability issues. Also, system configuration and resource availability issues are not part of the equation. So basically, this POSIX.1-2008 defines the user interface on the command line. So what we want are .1-2008 compatible. Why do we want POSIX compliance? Well, it's easier written with POSIX compliance to another. I use Ubuntu. ats-cis.jccc.edu uses, it uses CentOS. So, what do we need to do? To make sure that our shells are POSIX compliant, we'll keep the shebang line, that line that begins with the hash exclamation point, in other words, the pound bang, space, /bin / whatever shell name you want it to be, less than 64 characters in length. Because one of the things you can do is you can put restrictions or options for that shell in that shebang line, which is really good. The full path name may need to be specified. I suggest specifying the full path name regardless. Never assume that one machine uses the same path as another machine to get, and never assume that one user has the shell home in their paths. So always use the full path name, and you do that for security reasons as much as anything else. Now, that full path name can be problematic. It depends on where the shells are placed in any particular distribution. So you may have Joe Blow's Unix or Linux, and it may have shells in user bin. Why it would do that, we don't know. But there's many different ways of putting shells into a system, and many different places to put them. So the other thing you don't want to do is include white spaces after the options. Basically, you want the end of the line showing up right after you've specified options for the shebang line. You don't really need to talk very much about that, but keep that in mind when you're building shells. So, pieces of shells. So we've got variables. Those are names given to the pieces of information. For instance, in this slide, you'll see that myvar equals this is something silly. And if I set that, and let's go here, myvar equals this is, let's get back here. Let's get capitals. This is dumb. Okay. Now, what did that do? If I use the command echo on myvar, what is it going to give me? It's going to tell me myvar. I said echo what I've given you. Okay, and I gave you myvar. Now, when I put a $sign in front of myvar, I'm asking it to give me the contents of myvar. There you go. So here we've got that myvar equals, this is something silly. We echo $myvar and it gives me the contents of the variable myvar. Okay. You can output using echo-e. You can output with printf. So if I do that again, printf $myvar, right? This is Hugo. This part, this is dumb. Well, it's interesting because what printf did here is it sees the space and considers that the end. The other thing is printf doesn't give you a new line by definition. So you have to put the new line in yourself. So IO redirection. You can redirect the input standard in 0 using the ~n sign. You can redirect the output standard out 1 using the greater than or greater than sign. You can also use pipeline, which is the vertical column. And there's also special files that you want to deal with, dev-null and dev-tty. So shell portability issues. So where is bin shell? Well, let's go take a look. So in CentOS, bin shell points to bin bash. Interesting. Let's take a look at that. So which shell? sh. User bin shell. So ls-l user bin shell points to bash. Which bash? User bin bash. ls-l user bin bash. Okay. File bash. Yep. File. User bin bash. Okay. So there you go. There's the build on that. So now what happens when I do that, issue that in Ubuntu? Which sh? Bin shell. Okay, ls-l bin sh, right? Notice, shells are kept in user bin in CentOS and in bin in Ubuntu. Okay, ls-l user bin. Let's see what happens when I try user bin dash. No such file or directory, so it is in bin dash. Okay. File bin dash. Okay. So there it is for GNU Linux 2.6.32. Again, the bash is here for 2.6.32. So what's the difference between bash and dash? Well, bash is the born again shell, and dash is, let's see here, dash is the Debian-Almquist shell. So the major reason that they used to use the regular born shell, but the reason they switched, the Ubuntu switched to the dash was efficiency. Bash used to be where shell pointed to in Ubuntu. Now it points to dash. So bash is large, slow to start up and operate by comparison with dash. So a large number of shell instances are started as part of the Ubuntu process, and rather than make all of those shell instances start up with bash, they made them start up with this new smaller version of the born again shell, or the smaller version of a shell called Debian-Almquist shell. And dash, there's got to be, the pun has to be there. The reason is because it's quicker, so it's dash. So anyhow, that's kind of interesting. So even just in the Linux environment, you won't see normally a regular sh, the real born shell. You'll see it point somewhere else. So shell portability issues continue. So on the CentOS image with the user pointed at its user bin shell, the printf command on page 18 of classic shell scripting reports the following output. So if I do this, if I try this command, if I try this command in the ATS environment, let's do this, I'm going to come up with an error. Can't find that event and gives me this event not found. So when I do this in the Ubuntu world, and let me go back up to the Ubuntu image, let's paste that in there. It's the same thing I pasted in the other, in the CentOS image. I still get that. It's interesting, it's been fixed. There's a way around this, and it's kind of interesting. But we'll talk about that later. So, yeah, actually, we'll talk about that now. So let me try this. What have I done? Okay, so what is this? That's an octal 41, huh? What does that do? Ah. Let's do this. Let's try this. And again, it gives me this odd duck. Well, and there's a reason for that. Pardon me just a moment here. Control L. Let's paste that in there again. And we'll fix something here. This is called another reason why I love Microsoft. The double quotes are different in Microsoft's coding. So that's what you get. Okay, let's bring that back up here. Notice how that's a different set of quotes. And there we have, in essence, the problem that we see a lot with, let's see if I can get this to print correctly using the ball bat. So what's that octal 41? Would you believe that octal 41 is the code for the ball bat, or the exclamation point UTF-8. Okay, so that's kind of a little odd. Again, this is one of the reasons that I've asked that you not turn your projects in with Microsoft Word documents, is because there's a different character encoding in the Word document. It is not UTF-8. So again, here we go. The quotes are different. This is why I do not want you under any circumstances to turn in your projects using Microsoft Word. Okay. Shell syntax emulates formal programming languages. So the Bourne shell began as bin.sh. Being the original shell, it emulates a programming language that was known as Elgol. The C shell and Tenix C shell, TC shell, emulate the syntax of the later C language, and language is spelled very inappropriately here. The Corn shell and Bash shell use a combination of both shell and C shell, but in reality that may not quite be as good an explanation as we want. So the theory behind this change from the shell to C shell was fairly good. The input language was set to resemble C, and this was done in Berkeley, by the way. So the shell was simply too buggy to produce robust shell scripts, and so everybody stayed with the Bourne shell for that. But because it was better for interactive use on the command line, people used C shell to talk to the kernel. So C shell was the command line shell of preference. You built your shell scripts and you set the shebang line to bin shell. So after C shell was let loose on an unsuspecting world, various people decided that the bugs really should get fixed. So that while they were at it, they might as well add some extra features. In the command line editing, 10x style completion and several other features were inserted. So what the heck is 10x? Well, 10x was an operating system put out by the Digital Equipment Corporation. DEC didn't really want to license UNIX from AT&T. They didn't want to pay the money to AT&T to license it. So they decided that they were going to build their own OS. In fact, I had a friend that in the late 80s, early 90s, it may have been earlier than the late 80s, he had been to a UNIX World gathering, and DEC was passing out New Hampshire license plates with UNIX on it, and they said, this is the only UNIX license that we'll ever have. And my buddy actually ended up with one of those license plates. So anyhow, there's this 10x operating system, and 10x used a shell, and that shell allowed you to complete commands. So what do I mean, command completion? Let's see here. Let me go back to this, and let's see if I can find some things. So user bin DA S H ls dash literal. Okay, interesting. So you see what happened is that typing occurred real fast, didn't it? Dash and then literal. It happened very quickly. Well, what happened is I hit the tab and the command auto-completed, and that was something that came out of 10x. So that 10x style completion was then pulled into TC shell. Well, eventually David Korn from AT&T, who gave us the K shell and who I had an opportunity to meet and speak with when he came to Kansas City in the late 80s, had the bright idea to sort this mess out and created the Korn shell, the K shell. Bin K shell made its appearance. And it junked the C shell languages and reverted back to the Bourne shell language. But it also added in many of the features that made the C shell good for interactive working. Basically the best of both worlds. So the Korn shell then became part of cis5, but had one major problem. Unlike the rest of the Unix shells, it wasn't free. You had to pay AT&T for it, and you still do. Now, the K shell that I have, if I remember correctly, let's do this. Let's clean this up. Which K shell? Because I do have a K shell running around here. ls-l user bin K shell. Etsy alternatives user bin K shell. ls-la. Let's do this. etc alternatives user bin K shell. Bin K shell. So, that's where it points. Okay. So basically, I have an alternative version of K shell. It's a lookalike K shell. It does not really, it isn't a K shell, but it looks like one. So at some point during this time, after the K shell had been created in the 80s, it was about that time that the first attempts to standardize Unix started in the form of the POSIX standard. So POSIX specified more or less that cis5, a Bourne shell, B shell, or just shell, SH, was the standard. And then about that time, BSD and cis5 versions had gotten slightly different, well, more than slightly. So later the standard was upgraded, and somehow the new standard managed to look very much like K shell. Okay. So also at this time, GNU was underway, and they decided that they needed a free shell. So they created the Born Again shell. And like the Korn shell, it was based on a B shell language, and like the Korn shell, it also stole features from C shell and other OSs. And Bash put them together better according to the person who wrote this. So unlike the Korn shell, Bash is free. And because bash is free, bash is used everywhere. Everywhere I have been in the world, bash is in use. So that's what we're dealing with, bash. So meanwhile, Tom Duff, faced with the problem of porting the Bourne shell to Plan 9, Plan 9 from Bell Labs, revolts and writes this RC instead. And he publishes a paper on it. And he gets this clean start RC, which is a different shell. Well, eventually the search for the perfect shell goes on, and then there's this Z shell. So how do you decide on a shell? Well, how much time do you have to learn a new shell? What do I want to be able to do with the shell? So those are the types of things you're looking for with shells. So what is the shell? So it interprets your commands and acts as an intermediary between the user and the inner workings of the operating system. Most Unix systems have various shells available, and also most Linux systems have various shells available. And in a bit here, we'll go through what makes shells different. So again, let me go through Tenex C shell real quick. The T and TC shell comes from the T and Tenex, an operating system that was put together by DEC. So there's a built-in history, use of the up arrows, down arrows, a number of invoking previous commands using the command history and using history in new commands. Also command line editing. So there are a number of things there that you might want to take a peek at. Anyhow, now that I bored you to tears, this will be the end of week 5, and this is part 2, the end of part 2. There's one more part coming. Part 3 will come up in whenever you need it. Talk to you in a bit.